Alright, so today we're going to be doing the second part of graphing rational functions. This is going to include your points of discontinuity. This is different from how we did transformations, okay, because we do have holes in there based upon these points of discontinuity. Alright, and just to review, vertical asymptotes, factor of the denominator does not cancel with the factor of the numerator. Hole happens when the factor of the denominator does cancel with the factor of the numerator. Now, the brand new thing to this is how do you find your horizontal asymptotes? And it is one of two ways. There is actually a third, but in this course we are not going over the third, and so you'll see that in a future course. So the first way, the horizontal asymptotes, is that the degree of the numerator and the degree of the denominator are not equal to each other. When this happens, y equals 0 is going to be your horizontal asymptote. And if you forget what degree means it's the highest power of x. Now, the second way is if the two degrees are equal to each other, then you're going to have y equals the fraction of the leading coefficient of the numerator over the leading coefficient of the denominator. And if you've forgotten what leading coefficients are, they're the number in front of the highest power of x. So basically, if you have both of them written in standard form, it's the number at the very front of your expressions. So let's look at graphing these, okay? So our first thing to do is to factor everything, because that's what we've done every time we've been messing with rational expressions. So we factor out a 4 on the top, so you have 4 times x plus 3, and then the bottom is the difference of two squareds, which is going to get us x plus 3 and x minus 3. Now, as you can see, top and bottom, x plus 3 cancels out with x plus 3. And so therefore, because that one canceled, x equals negative 3 is going to be your whole. Remember, when you cross out the factor, it's always x equals the opposite of the constant. For the vertical asymptote, since x minus 3 did not cancel out, we have a vertical asymptote at x equals 3. Again, they're always aligned, so it's x equals, and you always take the opposite of the constant in that factor. And remember, the 4, we don't really care about at this point. They don't help us find holes or vertical asymptotes. So let's draw on the vertical asymptote at x equals 3. Remember to make it a dashed line because it's actually invisible. You can't really see it, but we need to draw it in so we can draw our graph accurately. So now we have to look at finding our horizontal asymptote. Okay? And that we look at these two right here. They're the highest power of x on the top and the bottom. Now, if there's not an exponent with that variable, it's always a 1. So as you can see, we have 1 and 2. They're not the same. The top one's smaller than the bottom one. So therefore, our horizontal asymptote is going to be y equals 0. So let's draw that in. So now, in order to find where our curves go, we are actually going to use our calculator. So in your calculator, you're going to type in your rational expression, but the thing that's important is to always put the numerator in parentheses, then divided by, and put the denominator in parentheses. And that's how you want to want to look like in your calculator. Now, if you hit second graph, it's going to give you a table of values. The table of values is what we're going to use to find points on our graphs. So I've already done that in my calculator, and I find I have a good point of -1, -1. So I'm going to plot that, -1, -1. There's another good point at 1, -2. Then there's another good point at 2, -4. Okay? So once we have some points on one side, we can follow their slope through the intersection of the asymptotes to the other side to find their partner. So if you take this point -1, -1, follow its slope to where the asymptotes cross, that's up 1 over 4. So from where they cross, you can go up 1 over 4, and there's your point. Likewise, if you do 1, -2, that's up 2 over 2. Up 2 over 2, there's its buddy. And this one at 2, -4 is up 4 over 1, so we can go up 4 over 1. And so this gives us a little bit more accurate of a graph. The more points you can find, the better you're going to be. Okay? And you can actually double check these points on your table. So we draw our curves here. We've got our first curve, and then we can draw in our second curve. Now remember, when you're graphing, we still have to put in the hole. So you always have to remember that. So this is at x equals -3. So if we draw our curve, right when we get to the line for x equals -3, we have to put a circle or a hole. And then we continue the rest of our curve. Okay? And notice that the curves do not cross the asymptotes. They're like force fields. Can't cross them. Okay? So, there's your graph. You have all the pertinent information: holes, vertical asymptote, horizontal asymptote, and when you draw it, you have to put that hole in. Okay? Now let's look at the second example, when the degrees are equal to each other. So again, the first thing we gotta do, we have to factor everything. Okay? So before I get started on that, I'm going to factor a negative out of the bottom, because that's going to help our cause, because now we have a difference of 2 squares. And so if you factor the top, what multiplies to -4 adds up to 3. That's going to be x plus 4 and x minus 1. And then on the bottom, we have the negative sign out front, and then we have the difference of 2 squareds, which is going to get us x plus 1, x minus 1. So now, the x minus 1s are the same top and bottom, so we cross those out, and that gives us our hole of x equals 1. Okay, remember x equals and then the opposite of the constant of the factor. So that means our vertical asymptote is going to be at x equals -1. Because x plus 1 did not get crossed out, and again, opposite of the constant gives us our vertical asymptote. So let's put in our vertical asymptote at x equals -1. There we go. Now we have to compare our degrees. So we have x squared and x squared. They're the same. So therefore, we have to look at the leading coefficients, which is 1 and -1. So now, this would be our fraction of 1 over -1, which in turn simplifies to -1. So we're going to put that on our graph. Okay, and again, make sure these asymptotes are dashed, not solid. They're technically invisible. Okay, so I've entered this problem into my calculator, and once again, if you type this in, you're going to go parentheses x squared plus 3x minus 4 parentheses divided by parentheses -x squared plus 1. Okay, putting the numerator and denominator into parentheses. That's the key. Okay, and then I'm going to go to my table, and I'm going to pull out some good points here. Looking at it, we've got the point -40, which is right here. We have the point -22, and looking at it, we got 0, -4, which is down here, which would be our -22's buddy that comes across. And then we have the point 2, -2, which would, again, would be the -40 buddy. So now we have our points, we draw our curves, and remember again, our hole is at x equals 1. So draw the curve, and when I get to the line of x equals 1, I put my hole. There we go. And my other curve, I'm not worried about a hole, so I'm just going to draw this and finish it out. Okay, so there are our notes on graphing using points of discontinuity. And the next one up will be simplifying rational expressions.